solve a problem, which is making an assessment of a disease. And the last one is maybe it's uncommon for us non-medical professionals, which is our professional. So let's start with the first one. So cancer in our abdominal lining, they call it our peritoneum, is one of the most hardest cancer. It is the symptoms when it starts is very similar to like diarrhea, if you're non-life-threatening disease. But it is very life-threatening, and usually it is correlated with cancer in the womb or cancer in other gastrointestinal virus. And as like any other diseases, surgeons or doctors in general, they need to detect the disease. So they need to do a prognosis, or they need to predict what will happen in the future in the patient, and then they need to make decisions, and then they need to evaluate the response to chemotherapy. Usually, if it's cancer, they will do chemotherapy. And then they will produce a metric, they call it retinal carcinoma index. This is one of the most reproducible, one of the most widely used metric to measure the distribution of chemotherapy. How many of the tumors is spreading your body? So they have like 12 zones in your body. And there are several detection techniques. The more traditional ones like ultrasound, like CT scans, MRI. Two are interesting. First one is called laparotomy, which is they do open surgery, so they do slice of your body to find cancer. As the second one, less invasive one, is called laparoscopy. Keep that in mind because it will be interesting. So next, please. So what are the challenges? Why do we need treatments? So with peritoneal carcinomatosis or cancer in the brain, there are a lot of tumors, especially when it is already spreading all over the abdomen. So it is very hard for the doctors, for the surgeons to keep track of all of those cancer. They don't have a specific standardized tool to know where is this cancer, where this tumor is from, and even though they have some kind of metric, but the high tumor is a big problem. And then it's followed on a lot, but it's very small. Especially if it's very early in the stage, there are a lot of very small tumors. And then your abdominal cavity is very intricate. There is there's your stomach, and there's other part of organs. So there are a lot of small things happening inside your stomach. So it's very intricate. And previously, all of this detection methods, they are not very high resolution. You know, it's very small, but your camera is not very high resolution. So it's very hard to track. So what is this doing? We propose computer systems. We want to be able for them to easily keep track of their tumors. And we focus on laparoscopy videos because it is the safest and most useful way because it does not introduce unnecessary morbidity like open surgery. This high resolution enough because you insert a camera inside the patient. So it has very good accuracy, it's 80.8% according to some research. Next. So we partnered with an institute in the city called Multimedia. So it's called Institute Cardiology to the US. We partner with some surgeons there. They are specialized in detecting this kind of cancer. So we take their inputs. We make it a user-centered, iterative design. And why we need this kind of custom-made system? Because hospital systems are not good enough. There are a lot of specificities, and there are be efficient enough for it to be good. And then we want for the surgeons to work together and work on a specification to make it progress. So surgeons will simply analyze data, simple group operation, and analyze the videos, and people will solve them very record the examination, and it will calculate this quantitative dimension. Next. Next, please. Architecturally, it is simple because this is not architectural design. Here is a simple front-end with a go backend. So we just use MongoDB for text storage, and we use Multimedia for files and videos. It is all encased in a Docker container. So three main parts of Kiko is first, we want for the searches to be able to take pictures, extract features from their laparoscopy videos. So we call it segmentation based zone. And then after they take the pictures, we want them to make annotations. We want to contour. They want to contour the area. We want this node is here. This node is in this part of the body. And then Kiko will automatically calculate this node their data. So after the surgeons give them the amount or then the spread of the tumor, they will easily calculate. Thanks. So to give you the overview. So this is a typical user journey in our Kiko. So here, simply they will have an account, and they will, this is their homepage, and here, they will, sorry, it's in French, but then they will create a mission here, like their ID and type of initial diagnosis, and then their underlying type. And then this is their main patient examination, so they will add other copy videos like they will as a video right here. And then can you close this? Okay, so here they will have this annotation page here. So here is the an image of your findings, so they will be able to create and insert images. Next, so evaluation is simple. So the environment here, we use their infrastructure. So they don't want the data to be in a public cloud. So we use their infrastructure in Pico. So we target them for our CPUs with memory or GPU limitations. Our evaluation methods is just we want to quantify, we want to disprove that the system is actually used by the surgeons, and we use system design with the scale. We give a questionnaire to the surgeons that use the system. Next. So there are 25.4 gigabytes of patient data across 76 patients, 8 examination videos, and all of them they have produced 884 images. We produced 87.5 or 102 score, but all of them say it's still cumbersome to be used in some areas, which is improvement for future outcomes. 2 minutes left. Okay, so what we have heard. So Kiko has successfully assisted surgeons in assessing peritoneal carcinoma, and our user-centered approach to make Kiko frequently used because we listen to the feedback of the surgeon in multiple forms, and we allow them to have high stability for future works. Because previously we have a lot of this annotated data, which means this labeled image data. For future works, we see used for training machine learning models by the annotated image used by this. That's all. Thank you very much for your attention. Okay, thank you very much. This round for thank you for presenting this work. Do you have any questions to the presenter regarding this surgeon collaborative tool? Yes, please.
Regarding the tech stack,
Can you tell me that architecture?
the tech
slide in Docker.
yes, there's slide number 5, not one more. Yes. May I ask about the reasoning of choosing the specific front end and back end for this project?
Okay. Sure. Okay, thank you very much. So, for the specifics is for Docker first, is because we don't want to deal with configuration issues, so we have our same environment, and then eventually we want to deploy it in their servers. So we use Docker because they already have Docker in their system. It makes configuration far easier. For Angular and Go backend, there were no specific usage. It's just because we were able to use OpenAPI specifications to generate most of the API endpoints. So most of the API endpoints are auto-generated. Usually, the menu chair CR3 UDX, CR3 endpoints are automatically generated, and they support Go, so that's why we use this particular stack for the data layer. We want to, because we did not have time to design databases, so we don't want to deal with relational database, so that's why we designed with HCMA. For binary files, we use ICTS because it is one of the most used open source platform to store binary files.
Are you fine with the answers? One more question, maybe?
All right, please. I want to ask that this cohorts in a way that Python can get files and then we use it for certain access to the system, or if there is more operation will be paired with certain
Okay, thank you very much for your questions. So, can you go into slide 4, please? So, throughout the process of eco, the patient does not touch the ecosystem. So, all the patients know is they go into the hospital and they have a problem with their stomach, and the surgeons will evaluate their ability to discover scope surgery. And for the surgeons to assess whatever happening inside the patient, the surgeons will manually upload the files into the system. So it's not patient at
Okay, thank you for the Q&A. Okay, thank you very much for the presenter, Mr. Guru, and the rest of the audience. This is from Moscow. Next, gonna be my paper, but I'm not gonna be the presenter. I would like to ask my student to present it from the Zoom meeting. So, yes, you may need to admit all the participants maybe, and then ask Akmal Zaki to start presenting the work. Okay.
Hello. Can I present my own screen, or it should be the existing screen that is?
Yeah, I think it's you could present your screen, Mr.
Okay.
Okay.
Can you enable the screen sharing because it's still not enabled yet?
It's already. Thank you.
Okay. Is it already displayed on the screen?
Yes, it's there, visible. You may
Okay.
start.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, Mr. Hazik, lecturers, and audience with my respect. First of all, thank you so much for the opportunity, and please let me introduce myself. My name is Akmal Zaki Asmara, and today I want to talk to you about the marker versus markerless in usability insights for indoor navigation with handheld augmented reality systems. I will walk you through our research in usability of handheld AR using marker and markerless method to determine users' position and guiding them in indoor spaces. In this modern era, the positioning system has become a crucial system in our daily lives. GPS is one of the major technological advances that helps our daily lives and solves almost the entirety of navigation problems. The thing is, GPS is not very accurate when being used indoors. GPS also cannot be used to help us navigate inside buildings due to its low accuracy within indoor spaces. These problems leads us to another system that has already been developed to mitigate this issue. So IPS or indoor positioning system is like GPS but can be used indoors. Multiple localization methods were developed to determine user position within indoor spaces. Some of them replicate the way GPS works by using signals like Wi-Fi, infrared, etc. But others also use computer vision to recognize the environment, like QR, image recognition, and point clouds. So there are some attempts to develop an AR-based IPS to improve the IPS app quality. By fusing real-time sensor data with virtual overlays such as lines and arrows, AR has enhanced spatial awareness and provided users with intuitive visual cues for navigation and object identification within indoor spaces. This technology, however, has several complexities that the developer needs to overcome to align the virtual and physical worlds. One of which is the usability of the system. Previously, the development of AR system was mainly concentrated on how the systems can register the present information within the environment instead of the user interaction with the system. So our research focused on comparing the usability between two different localization methods utilizing CV in AR-based IPS, marker-based using QR and markerless using LiDAR-generated point clouds. In the process, we also briefly explored the performance comparison between these two systems. So in carrying out this research, we used some studies related to AR-based IPS. The first paper discussed about developing an AR-based IPS using QR codes. While testing the application, the author gave some recommendations on using QR code as the localization system in AR-based IPS. So it is recommended to have light intensity of 97 to 160 lux to achieve optimal scanning results. And the device orientation also needs to be adjusted between 70 to 95 degrees for the device sensor to work when navigating around spaces. And the test results obtained showed a good level of accuracy with 96.6% correctness of detecting rooms. And the second paper compared the usage of AR eco markers instead of QR codes. After conducting some experiments, AR eco markers performed better in scanning than QR codes in some aspects, such as vertex scan distance and flexible scanning orientation. And the third paper developed an AR-based IPS utilizing point clouds in hospital environment. The point cloud was generated using two different methods. The first one using mounted LiDAR camera with Matterport Pro 2, and the second one using iPad Pro 2020 with Vivaria Area Target Creator application. The author stated that point clouds generated by a mounted camera produced significantly more detailed results compared to iPad Pro 2020. The last paper compared the effectiveness of physical 2D map and AR-based IPS utilizing point clouds by calculating the time differences to reach the destination. For 92.5% of the observations, AR-based IPS utilizing point cloud had a shorter navigation time than a physical 2D map. Okay, now let's move on to our methodology. So both of our system was built using Unity and followed the same design process as depicted in this flowchart. The main idea is to use device camera output to recognize features such as or point clouds to determine user position. Then the user must manually input target destination and the system calculates the shortest path using nav-mesh pathfinding. The localization method was handled on its own and different in this system. To ensure both systems have the same functionality, we listed 5 functional requirements that both systems need to fulfill. These functional requirements will be used as benchmarks during our usability testing process. It's worth mentioning that the usability testing in AR systems is slightly different than in desktop apps, and there are some challenges that we need to address. There are such as hardware limitations, participant novelty effect, consistent evaluation environment, and the lack of AR-specific heuristics. So when conducting usability testing, we may want to track our participant behavior on screen by looking at screen recording, or using third-party apps to utilize features like heat maps. In AR usability testing, looking right into the screen can sometimes be very difficult. It can be caused by the participants moving around so that we have a difficult time tracking their actions on screen, or because your application runs on a head-mounted display, which requires you to have a screen mirroring apps to see what's happening in the application. Therefore, hardware limitation can be one of the challenges in usability testing. Another one is novelty effect. When testing your apps, participants may experience something that boosts their curiosity and makes them rate it more attractive despite their performance. This effect may wear off as they use their product more, causing a decrease in user perception ratings. Another challenge is the testing environment. An inconsistent environment such as flickering lights may affect the visibility of on-screen text. And the lack of AR-specific heuristic could also be one of the challenges when conducting usability testing. But even though there are no standardized heuristic for AR apps, we can still use Nielsen's test usability heuristics. To mitigate those issues, we adjusted our testing and tried to use a dedicated usability evaluation framework proposed by Yi-Yin Cho. The proposed framework stated that there are 5 components in ensuring a successful evaluations and collection of useful usability data. The first one is evaluation scope, which is determining which functions or features to be evaluated. So we are not going to test the entire system, but only some of them. And the second one is identify the correct users and the context of use. The third one is defining the scenario or tasks that the user needs to complete. The fourth one is select applicable usability metrics. And the last one is define measures for the selected metrics. So we applied those components in our usability testing and made some adjustments to fit into our research purpose. The first strategy is by limiting our evaluation scope. Before conducting usability testing, we define our evaluation scope first. This strategy will ensure us that the results obtained will be more focused to what we want. In this research, we want to focus only to the usability aspects of the localization systems. We want to know how good the experience is when the app is being used by the users. We also define who our user was and specify the context of use before conducting the usability testing. Our testing participants were a person who is very likely to wander inside buildings. In our case, it's a college student. And we also try to ensure that our test participants have enough knowledge or understanding in AR systems, or ever used an AR app before. This is to reduce the novelty effect that may occur during testing process. We also limited on-screen interactions by only displaying the necessary feature. The only interactions that the user have with the system is marker scanning feature for QR system, localization success feedback, setting destination, and displaying the path to their destination. This way, we don't really need to extensively monitor their behavior on screen because the user will be focused to one feature at a time. And because we limit the on-screen interactions, we gave the tutorials by oral introduction and letting them to be familiar with the app beforehand. We do this because we want to preserve the first component of the framework that I mentioned earlier, that is evaluation scope. Our usability testing was conducted by asking the participants to use the app to localize themselves and navigate between points in the building. Participants were asked to fill a system usability scale SUS questionnaire after completing the task. Other than usability studies, we also conducting some performance tests on both systems. There are a lot of metrics we can use to measure the performance of an IPS, but in this research, we used IPS aspects proposed by Hui Liu. There are 6 aspects, namely accuracy, precision, complexity, robustness, scalability, and cost. So after conducting those tests, we found that QR code has better accuracy and precision in 2 testing sims. So to explain our testing sim in accuracy and precision, the first one is navigation sim. It is conducted by obtaining the MDE, the mean distance error, in consecutive predetermined points, or in simple terms, getting the MDE by walking through all the predetermined points. And the second one is using localization sim. It is conducted by obtaining MDE only in specific points multiple times, not in succession, or getting MDE by localizing in numerous times in a single point. And QR codes also had a faster localization method than later point clouds. In point cloud-based systems, the app needs to detect multiple features in the environment in order to determine the correct position. Meanwhile, QR code scanning is almost instant. But QR system lacks of flexibility when handling repositioning. Repositioning in QR-based systems need to be conducted in specific areas where there are QR codes installed in the environment. On the other hand, a point cloud-based system enables the user to directly reposition if there occurs a drift when navigating, as long as the environment has already been mapped. So when talking about system scalability, both systems are easy to scale and integrate to the existing system. We can expand the coverage area, but just map the area you want to add to the system. But QR offers more flexibility in integrating the new mapped area. So if you somehow store the map areas using JSON and store it in database, we can update it directly without building the app and redeploy it. But this method is difficult to do in point cloud-based system. So the system cost actually quite predictable. QR system doesn't really need complicated hardware. So if you decide to store your map areas online, you might want to consider to rent a server. But in point cloud system, we need a leader-equipped device to produce the point clouds. Meanwhile, from 11 test participants, the usability test result showed that AR-based IPS utilizing point clouds had a higher usability score than QR-based. This phenomenon can be due to the ease of localization system that is provided by the point cloud system. The repositioning feature helps the user mitigating drift that may occur when navigating indoors. The app will immediately fix its position measurement and recalculate its destination path if any drift occurs during the navigation process. On the contrary, a QR-based system doesn't have the ability to do so. A specific QR code installed within the environment is needed to start the localization process. So to sum it up, both systems could have high usability indicated by their high usability scores obtained from usability testing using SUS questionnaire. Even though lacking in terms of accuracy, precision, and complexity aspects compared to QR, the point cloud.
Excuse me, Mas Akmal. It's already finished. You could go to the Q&A session, Mas Akmal. Thank you. Give applause around.
Ask the group because I don't think they should ask the question to my computers. Do you have any question for the presentation? Thank you. Maybe we'll ask this question. For the presenter, can you please explain how you do to navigate the user after you scan the QR code? What kind of method or approach that they use to navigate the user? Can you hear the questions? So basically, the question is about the specific procedures for the users when they take QR code as the tool for their navigation.
Oh, specific procedure when conducting the test with QR.
Yes.
Is that correct?
And then
Okay.
navigate the environment after scanning the QR.
Oh, yeah. So we conducted two different localizations there, two different testing sim, the navigation and localization. So before doing those tests, we gave the tutorial first to the users, like how to scan the QR and maybe a little bit time for them to familiarize themselves with the apps. And then after that, we give them clear instructions to how they're testing the app, like go to certain points with the navigation turn. And then after that, we maybe like giving some questions to them, like how they feel about the application. Is that?
Yeah, okay. Okay, thank you very much, Zaki. It seems that our time is up, so we need to move to the next presenters. All right, thank you. Round of applause for Zaki. Now we move to the third presenter, which is sent by another student. Can you address Hasna in the audience? Hasna?
Yes.
You ready for the presentation?
Yes, I'm ready, Miss.
Oh, okay.
So you need to use her own screen.
Is my
Yes.
screen
You can see that. You may start.
okay? Hello everyone, my name is Hasna. For the next 15 minutes, I will present about out at various swapping stations while electric scooters, QR code versus RFID interaction designs. Here are the authors of this research. There are Hazik Praboyer, Fairuz Hasnarofifa, Ridho Rahman Haryadi from Institut Teknologi 10 November, Iza Wahyu Firmansyah, Muhammad Ilham Firdaus, Muhammad Rifki Paki from Wiksarya Pratama, Imam Kuswardayan, and Darlis Herumurti from Institut Teknologi 10 November. Electric vehicles are gaining popularity due to their potential to reduce greenhouse gas emissions and reliance on fossil fuels. With the rising demands for electric vehicles, the development of battery swapping stations, or BSS, has become essential. This research delves into the interaction design for battery swapping stations, specifically targeting electric scooters in Indonesia. We compare authentication methods at BSS using quick response codes and radio frequency identifiers. Participants were asked to authenticate using both methods, and the study measured the average time taken for each. While RFID proven faster in terms of authentication time, user preferences between two methods were split, making it inconclusive which was superior overall. We're moving on to introduction. The international M20, there were 10 million electric vehicles globally, accounting for 4.6% of total car sales. In Indonesia, electric scooters have gradually begun to challenge the dominance of traditional fossil fuel motorbikes. However, the limited battery range of electric vehicles pose a significant challenge, necessitating frequent recharging. Battery swapping stations emerge as a promising solution, enabling users to exchange drained battery for fully charged ones swiftly. This approach garnered attention from major global operators aiming to enhance operational efficiency and diminish emissions. Nevertheless, the interaction design for BSS was still a burgeoning research domain. While systems like Taiwan's Gogoro offer insights, their design approach did not align with the battery designs of Indonesia electric motorcycles. For example, like the socket plug-in in the Taiwan is on the bottom of the battery, and for Indonesia battery, the socket plug-in is on the top of the battery. This discrepancy underscored the need for tailored research to devise a BSS interaction design compatible with Indonesian electric motorcycles. Our study zeroed in on this niche, focusing on BSS interaction design in Indonesia. We proposed an assess design that integrated authentication mechanism using quick response codes and radio frequency identifiers (RFID). QR codes have advantages like high data storage, rapid scanning, omnidirectional readability, and small printout size and error correction. On the other hand, RFID have advantages like offer universal applicability, efficiency, longevity, quick data read-write capabilities, memory capability, and company and consumer advantages. Previous research has explored various applications of RFID for authentications. There are an intelligent parking application where cars equipped with RFID tags could seamlessly enter and exit parking lots. RFID-based toll gates where EZ Pass tag facilitated electronic toll payment. Functionality of a smart card for secure payments in electric vehicle charging. And supply chain dynamics of the electric motorcycle business with a swappable battery system. In this context, QR codes were employed for authentication at the battery swap station. Despite these advancements, no study has directly compared the usability of QR code and RFID authentication methods in the context of battery swap stations. Moving on to methodology. The BSS battery swapping station examined in the study was owned by PT Wiksadaya Pertama, a prominent BSS manufacturer in Indonesia. This BSS allow users to swap their depleted electric batteries for fully charged ones. The transaction process involves users interacting with a BSS machine to perform several tasks, inserting a drained battery, making a payment, and collecting a fully charged battery. This is a picture of BSS machines which have EQS display as graphical user interface and battery slot to store the battery. It is the system architecture of the battery swapping stations. Here in BSS machine, we have EQS display, which communicates with back-end servers, send and receiving data via RESTful API. EQS display communicates with two microcontroller, STM32 and ESP32. SM32 communicates with battery slots and other hardware. Meanwhile, ESP32 communicates with RFID SC522. This module is used for scanning card for RFID authentication method. PT Wiksadaya Pratama BSS had already incorporated a QR code-based login. And in this research, we introduced an alternative login method using RFID. We then plan to conduct experiment with testers, sharing the time they took to log in via both methods and gathering their preference and justification and comparing the two methods. Before initiating the battery swap, user needs to log into the BSS. There are two login available. For the QR code authentication, users scan the QR code display at the EQS display using scanning feature in the Wixa Swap app mobile application. For the RFID authentication, users tap their ID cards in RFID reader. And before using this method, user had to register their ID card within the Wixa Swap app. After authentication, user can insert a low power battery into an empty battery slot. And then the EQS display shows a confirmation transaction page, which show a percentage old battery and the new battery. And then user can do the payment via the user's coin balance. This coin-based payment method was adopted to minimize dependency on mobile phones during transaction. After payment, user could collect a fully charged battery from the BSS. We're moving on to experiment and analysis. An experiment was conducted to ascertain the time needed for login at the BSS using both methods. 10 participants were recruited for this study, and the experiment procedure is as follows. Participants register an account on the Wixaswap application and ensure their account balance was sufficiently fund for 2 transactions. They practice a battery exchange transaction at the BSS without any authentication. Each participant execute a battery exchange transaction at the BSS using the QR code authentication method and another using the RFID reader method. The sequence of these methods was randomized. Post experiments, participants were queried about their authentication method preference and the rationale behind their choice. And this is the experimental results from the 10 participants. This is the login time, total transaction time, and this is difference time. This is the transaction time without the login time. It can be noted that average login time for the RFID reader is shorter than the QR code method. However, in terms of transaction time, The initial method attempt by participants typically took longer than the RFID reader. This is also RFID first took longer than the QR code. Regarding preference, when participants asked about their preferred methods, the group was evenly split. 5 participants pick QR code and 4 participants pick RFID reader. From this affinity diagram, several insights emerged. Participants favoring QR code found it more straightforward, primarily because they frequently carried their mobile phones compared to their ID cards. Conversely, those preferring the RFID method appreciate its simplicity because it eliminated the need to access the mobile app. And participants with slower mobile phone also said the QR code could be time consuming. And for the conclusion, a novel authentication approach for battery swapping station catering to electric scooters in Indonesia was introduced. This method entailed user authenticating by tapping their ID cards on a RFID reader at the BSS. To evaluate the efficacy of this proposed method against the profiling QR code authentication, an experiment was conducted with 10 participants. The primary metric of comparison was the time taken for login using each method. The result indicated that the RFID method was more time efficient than the QR code method. However, when participants were polled about their preferred authentication method, the group was evenly split, so a definitive conclusion on the superior method remains elusive and warrants further investigation. That's all. Thank you. If you have any question, you may ask.
Yeah, thank you very much, Ms. Ronald, for the presentation. Do you have any questions? Matthew, go ahead.
If the experiment has any or particularism on the environment situation when the authentication happens.
So the question was whether during the experiment you consider the environment, the situation in the experiment room or the place when you conduct the experiment is part of what was that? The part of the variables that you need to consider. Do you get the question, Hasna?
Yes, but no, for now, the environment not included in the variable of this research.
Yeah, so basically the confounding factors, right? So we were not considering that, unfortunately. Yes, then maybe that's going to be part of the further studies. Thank you, Matthew. Any other questions? It's not, then maybe we can go with the next presenter. Thank you, Hasna.
Okay, thank you, Mr.
Okay, now let me confirm whether Dr. Hani Hari asked this room, or is it online with Zoom participants? Dr. Hani, are you there with us?
Yes, I'm here.
Great. Do you want to share your screen or is there?
I'd like to share my own screen.
Okay, good. Right.
Thank you very much.
You have 13 minutes to present your work and then we continue with the question and answer session in the last 2 minutes. Okay?
Okay, thank
You
you.
may start.
Yes, I will start my presentation.
Yes, you can see it's
Okay.
visible. Let's see it again. Are you good to go?
Okay. Oh, okay. So thank you for the opportunity to present our research with the title of activity design based on activity learning. appreciative learning with in disaster mitigation. Series game, we are the researcher in game development in Universitas Nusantara, and I and Irianto will present the research in this session. So, from its geographical location, Indonesia is disaster-prone country with high disaster risk potential. So, therefore, the disaster mitigation efforts can minimize material losses and casualties in the cycle of disaster management stages. Mitigation enters the pre-disaster stage, which is part of disaster preparation. Mitigation consists of actions to minimize the impact of a disaster before it occurs. Therefore, it is important to introduce disaster mitigation from an early age. So, in this study, we use series scheme because it has the advantage to introduce the material, course material to the player. Series game has the advantage over other learning media, that is interactivity and experience. In this study, focus on the series game experience. One of the key elements for successful game is experience, which is built upon the game activity. So the problem that obvious here is there are not many works in series game that emphasize on game activity design. In most series game, the game activities are poorly designed. In this research, we use acquisitive learning as the fundamental concept to design game activities and enhance the immersive experience. Acquisitive learning embraces the discovery of potential, big achievement, opportunities, and hope from the future. We have four stages for acquisitive learning. There are the discovery, dream, design, and destiny. Then acquisitive learning-based activities are implemented to create more dynamic, immersive experiences. Okay, so one of the key elements of game experience, series game experience, is immersive experience. So we have three types of immersive experience that can be distinguished as sensory, challenge-based, and imaginative. The imaginative immersion have received relatively little research attention, and therefore this research will be focused on the imaginative immersion. Okay, so in this study, we focus on the imaginative experience here that are part of the immersive experience offered by a immersive experience design. So the three types of immersion in this experience are sensory, creative, and challenge-based. An immersive experience that involves the five sense, such as visual and music, is called sensory immersion. And then for imaginative immersion is related to the worlds of environments created in the games, including characters and story. The obstacles that the game presents are related to the challenge-based immersion. An immersive game experience can be achieved by effectively combining these three experiences. So in this game, we have four acquisitive learning states that we implement to the immersive element. They are discovery. From the discovery stage, it mapping into the imaginative immersion, and then dream stage, it mapping into the imaginative immersion, and then design to imaginative and challenge-based immersion. And destiny, we have destiny stage mapping into challenge-based immersion. So we have developed an example games for the testing purpose. It is called Evacuator. This is game for disaster mitigation. So in this game, we have four elements of positive learning. From the discovery stage, in the game activity, we design the game activity based on the discovery stage is the players is a display of all available survival kit items and their text. And then the dream stage, a player begin to learn which items go exactly in the bag. So maybe we could see in the next slide. So from the discovery stage, we have the player see all the items in the screen. So in the dream stage, we try to give the objective of the player, and the design it is also in the dream design stage where the player will tag this item to the correct tag, and then the destiny stage, if the player tag the items to the correct tag, then they will have the rewards. So we have conducted a questionnaire to the several respondents based on game experience questionnaire. More or less the questions, and we have 15 elements in these questions that mapping into the immersion type. So from the overall score from the questionnaire, we have, so without the positive game activity, we have around 3.1 from the score, and with the positive game activity, we have around 3.3. So there are slight improvement for the experience the experience that offered the series game activity. Okay, so in this experiment, we have a slight improvement in the prior experience using positive learning and to enhance the immersive experience. But there are some drawbacks in this research. This research is not tested. It's more complex scenario. The game is pretty simple, and we have still a long way to validate the effectiveness of the model because we have limited respondents, and the game is also very simple. So thank you for your attention.
Thank you very much. Please, you can pause now.
The audience, do you have any question to the presenter? The platform. Okay. There's a question from the audience. What was the platform do you use for to develop this game?
Okay, the platform to develop this game, we use the platform is the desktop. Yeah, so we have the Evacuator is desktop game, so we use mouse click and keyboard to control the game. So in the future, we also have a mobile version, and also for the iOS and Android version for this game.
How is about the framework, or maybe you mentioned about the game engine that you used?
Okay, we use Godot engine to
Godot.
develop this game.
All right. All right. Thank you very much for the answer. It's good. Okay. Another question from the audience. What about the online audience? I forgot to ask the participants whether you have some questions to the presenter. You raise your hand to see that. Raise your hand. That's okay. Nobody raised their hand. Alright, one last question from me, Dr. Hanu. Why did you limit your framework, this activity design or appreciative learning framework, only to serious game? Does it mean that it cannot work for any other type of genre?
Okay, thank you for the question. So I limit the we only focus on the sales game because we know that sales game is not as successful as the commercial games. So for the commercial games, they have many frameworks that working, but for sales game, we see that is very few sales game that successful in the market. So most of them is just stop in the research paper, and we cannot see the product, the sales game in the end user. Yeah. We almost cannot find a good sales game in the market. For example, we see that we have a flight simulator maybe that is a good sales game, but maybe some because of this game, so the developer is very good. So but for many reasons, the sales game is stop in the minimal way to reach the end user. Most of them just a web based, not a mobile based. If there are any mobile based series game, most of them is not as successful as the commercial game. So we try to give the series game framework to so that the teacher or someone who would like to design a series game could have a solid framework to develop the games. Thank you.
Okay, thank you very much, Dr. Hani, for the answer. This is the end of your presentation, so please give round of applause to Dr. Hani. Maybe we can have a short trip to hear the island first, and then after this we continue with the next presentation. I think we can continue. The next presenter is Dr. Fatima from Symbiosis Institute of Business Management, Pune, and Symbiosis International Deemed University, Pune, India. Dr. Fatima, are you with us in the Zoom meeting? So I guess we can skip. Yes. It's your turn.
So should I share?
Do you want to join the Zoom or? I think you should join the Zoom. It will be easier for you. You can control your presentation still on your laptop? Yes, great. So that's what we want. Awesome. The next presenter is Dr. Ovi from Denmark Christian University. And she will talk about unification of learning management system, improve students' engagement, active learning, and performance. Dr. Alvin, you have 30 minutes to present your work. You may start as you ready.
Good afternoon, everyone. My name is Multimedia. I want to present our research work with the title Unification of Learning Management System, Improve Student Engagement, Utility, and Performance. It is actually our background study. The learning and learning are driven by Moodle platform. Due to COVID-19, I think we can say that before during the COVID-19, the education still keeps running because of the learning. But after COVID, while the students come to school for the online school, and then we can see the habit of the student become different. They are very difficult to concentrate. They just only focus for daily basis. At the time, I'm very surprised what happened with our student at the time. And then I learned from several paper that actually the student is gets treated to teach relevant and flexible learning environment. They prefer using smartphone and tablet. And then at the time, LMS gamification is not the right fit for them. So that's why at the time I can understand what the problem with the student. Our student is against that. They study in undergraduate and graduate student. After that, I try to find the platform Moodle actually offer gamification through the plugin with the XP nature, so many wide use currently. This is become our motivation to apply LMS gamification in management information system and ICTS class to boost the student engagement and motivation. So it is our motivation. Actually, this is what is it? The roadmap of the gamification. From this roadmap, we can see there are several researchers that use game element, for example, gadget, leaderboard, and point and rainbow. Maybe we can see for the examples, this one is the game element. So to boosting, to make motivation the student, we can apply level up in LMS Moodle. So the student do activity, they will get the point. After get the point, we'll increase the point, and then the student can receive the gadget. The gadget to become gadget 2, how many points should be collected? And then also the student can see the leaderboard, so who become the winners. It is actually motivate the student. They want to complete what is better. Actually, for the teachers, it's very easy how to set up for these videos. But for example, we can make a point and then what activity will be count in this game. So actually, this one is a game element. From the previous research, the people just only use a conventional activity. So this means might be like the quizzes, and then also might be discussion forum, and then assignment. For example, the conventional activity, give sure and sure the question for the student, and then also might be other question. Make a drag and drop the text, and then matching question, and then multiple choice. Actually, this is the first, the researchers who like this one. And then another activity it is, we can see this one is actually game activity. Use the user interface for crossword, ciphertext, hangman, and then snake and ladders. Maybe you are already familiar, right, in this game. I can show the user interface. So this is how to make the student interactive and then intuitive to join with these courses. Because I use the user interface like snake and players, crossword, ciphertext, and hangman. We use the main question and then randomly by LMS to show up to the student. So actually, the student go together in the same class. Might be the crossword, the question become different because the question is taken from the main question. So that's why it is very interesting for the student. And then we can see the previous research, they just only evaluate the game element, only the survey game element as the previous researchers. And then they just only use a statistic, pair sample test to check before and after game elements they use. Only evaluate this one. And then evaluate for game element and activity only a few researchers. But our research gap is how to explore how much do the student engage and active learning to influence the student performance. It is actually the research gap, and then this one is also become our contribution. The question is, does MIS student performs implementation gamification, visual become LMS gamification different from traditional teaching method? And because LMS not yet gamification. How much do student engagement and active learning influence MIS student performance in LMS gamification? Our methods, we use the student grade for the semester 2020 to 2023. Actually, we have 5 classes. The first class, B1, around 38 students, apply LMS gamification. We want to enhance engagement and active learning. And then another class, don't use gamification. So, for 3 weeks, the student did get activity, and then we also give the midterm and then the final exam. The activity we use is snake ladder, crossword, hangman, and ciphertext. The question of quantitative methods is it test to compare student performance in LMS gamification and non-gamification. And then also we use multiple regression to measure the effect of student engagement in gamification activity on student performance. So what is the result? We can see from here, independent sample tests show that the student gamification have a mean 72.11, and then student without gamification, the mean score is 26.28. From here, we can see the difference of means is 9.83, and then we can check from the p-value, it is a significant. So we can see from here, gamification and not gamification, it is a different very significant. And then also for the next result, we can see, in this result, we want to check independent variables, student engagement, and then gamification activity. And then the dependent variables is the student performance. We can see here from this table, the hypothesis all is supported. And then from this table, the result from SPSS, we can perform the equation like this one, performance, engagement, activity. All the side is positive. What this mean? It means the student engages with the activity, so it means the performance become improved. But actually, only the student engages the activity, it is not enough. But if the student active with the game activity, so it means it is more performance will increase. So our discussion become episode. Yeah, as a definition, we can see that both the student performance and engagement, improving the SM score. And then game learning motivates students and enhance the participant. We can also find that gamification learning provide immediate feedback because the gamification element enforcing positive learning habit for long-term success. And then game activity, as we can see from the definition, enhance student engagement, making learning enjoyable because they like play the game. And then get a good motivation. Yeah, you can see here, create a positive immersive environment with a continuous feedback. And then we can see here improve the performance. Okay. After that, enhancing the academic performance significantly impact academic performance by performing deeper understanding and activity learning. Personalized experience because the game, progress tracking, tracking, and then feedback big student motivate and learn better academic outcome. So our conclusion, gamification has improved student performance and enthusiasm for learning. Gamification activity, learning and then student engagement in LMS, improve the academic performance and potentially transform education for long-term success. And then for the future research, we consider more game activity. It is only for actually there is a lot of activity games in LMS. And then we use mixed methods with the survey LMS gamification interest. Like the previous this presenter, they present. Okay, choose. Which you
You may stay standing here. Okay. So let's discuss her topics. Go ahead. Okay, good afternoon. My name is Yudhit. I want to ask a few questions. The first one is, what are the basis or framework that used in this research to construct the game elements? And the second one is, will this research work in every subject, plus subject, such as maybe math, PE, or physics, chemistry, or etc., or only in several subject classes?
Yeah, okay. Thank you very much. It is very interesting question. Yeah, actually, I use the platform Moodle. Yeah, Moodle is actually the platform for LMS. And then a lot of community, they build the gaming and then they plug in to LMS. So actually in my research, I don't create a new game, but I use the game for the classes. And then what kind of courses I can apply for this game? Actually for all the courses. You know what paper I did? Algorithm, they use also the game. Yeah, maybe this game already know you. Actually, There are several games. There are several games, but I only use one. Also in LMS, there is also databases. Can you include in LMS? The student can write the SQL and then show up the result. Yeah, this is only four examples of the LMS.
So two of your questions were answered. Okay, thank you very much. Do we have any other questions from the floor? Thank you.
So,
Go ahead.
so from your previous explanation, I did that you use online platform for the verification.
LMS.
Yeah, so do you consider like the psychology of the students to get the engagement?
Psychology. I think, yeah, for the psychology, I just only see the approaches for the student with this kind of ability because only my course for the first time implemented this game. So the student only approaches. But one of the students saying that, man, I don't agree with this game. Yeah. For the other, they are like this game. But for this one, they were like scared. Maybe behaving people if can do something. If we fail to answer, one of the body will end in this part. And then if they guess another character and then wrong, the other body will end. So maybe only this game, the student learn it.
Thank you very much. And I think the time is up, right? Thank you, Dr. Afi, for your presentation and the Q and the answer. Please give thoughts on the moment. The next one is Dr. Muhammad Darmawan. I'm here. So that should be in the Zoom participants.
Yes, I'm here.
Darmawan, are you with us?
Yes.
Okay, good. So Dr. Darmawan is with the Institute of Technology of School of Management. For all the authors also from the Institute of Technology School of Management. He will present his work about monocular estimation modification system. Fixed-to-fixed model with SE, LG, and alpha dropout. Are you ready?
Yes, can I share
You
screen?
may start to share your screen. You can try.
Okay, thank you. Okay, so this is thank you for your time to attend my presentation. My name is Muhammad Darman Fadilah as author of one, and then my friend Arifah Nur Ainah is the second author, and then we also have our counselor, Dr. Engineer Pak Darlis, Heru Murti Eskom MCom, and then Mr. Imam Puswarjayan Eskom MTech. Okay, we are from Institute Technology Blue November, Faculty of Smart Electro and Informatics Technology. Okay, so we are going to present about our journal, which is monocular depth estimation modification using fixed-to-fixed model with SELU and alpha dropout. Okay, so the first is the background. So when we driving at the night, we face an unique challenge, including pure visibility of object and obstacle due to low lights, which means if we travel using car in the middle of the night, when there is low light, when there is no lamp in the around, this is poses safety risk and hinders decision making. You cannot see anything when it's dark. To address this, long-range sensing or real-time image depth estimation technology can help by providing distance and depth information to assist drivers with hazard warning and collision avoidance. So to avoid in the middle of the night due to low light and everything is dark, we use image depth estimation to help a driver to make decision. Okay, so this is monotone estimation can be used to estimate the depth of objects or surrounding environment using RGB. And the benefit is the use of self-driving cars to identify obstacles, plan routes, and make decisions based on accurate depth understanding. The solution is using a pix-to-pix model. The pix-to-pix model will take input image from the camera and then generate a corresponding depth image that matches the input image. Okay, so this is our dataset. The dataset is collected from kaggle.com. This is pix-to-pix depth. So in this kaggle there is 1.53 gigabytes with 80,358 images. The training is 80%, validation is 10%, and the testing 10%. But in our journal, we use a process. The dataset is already processed with stereo depth estimator using this GitHub. It helps us with advantage like it has smaller size, and then it's specially designed for this custom code in pix-to-pix model. So there's other datasets besides this pix-to-pix depth like NGU depth dataset, Mac3D dataset, and virtual datasets can be used for this pix-to-pix model. So it's not only pix-to-pix depth in this kaggle, but there is other dataset can be used too. This is our method. So the first is real data from the camera. We use generator to make estimation depth, monocular depth, and process the fact data. Yeah, so the real image is the real image from like camera, and then the process to fact data to be RGB, and then the next part is to be processed in discriminator. So the discriminator will decide is this the fact data real or fake. I mean, if the discriminator cannot decide if this is real or fake, then it's the generator process a better result. So if the discriminator think it's fake, so it needs to continue generator to be process the fake data again, and then it keep training until the discriminator get the lowest. So it cannot decide it is fake anymore. The discriminator will think it's real. Generator will keep training it. Okay, so the next thing is the modification. We are using pix-to-pix model, which is we modification it using adding hardware parameters. First is learning rate. We increase the learning rate from 0.00015 to 0.002. There is increase 0.0005 increase. And then the next thing we use value using this journal. Value alpha dropout and value. Sorry. So this is the modification from. Okay, sorry. So the paper in this paper suggests that we use value and alpha dropout to have a better performance. And then you can see that there is in the generator from the original using value and then using leaky value alpha in this original. So we decide to modification using value and then using alpha dropout in here. So the original using dropout, and then we modify it using alpha dropout because the previous journal thinks that Celu has better performance with alpha dropout. And then the next is the result. This is the result from our training model. Okay, so in left there is original, and then the right is the modification. We can see in the 14 and 15 epoch that there is better performance on our modification. So you can see that the modification has better result for discriminator and generator losses. Better than the original fix-to-fix model. And then this is the result from the modification. So you can see that from in the left side, it's real data from the camera, and then we process it using generator, and then this is the output, the monotone estimation in RGB model. Red means it's close, and then blue means it's still far. And then in the left is original, and then the right is the modification. We can see that there is a increase in discriminator loss and generator loss. In the blue is the original, and the orange is the modification. You can see it's have better result, but the image still look the same, and it's not really the far with original. And this is our conclusions. So we have better at reducing losses and enhancing training process, but still the image still look the same. So we suggest that the pix-to-pix model can generate image that meet expectation, contributing the better image transition technique. Further work should comprehensive evaluate additional factor influence differences between modified and original models, possibly exploring the different modification strategies. So we think not only the discriminator and generator loss that need to modify, but using other method like data augmentation, hyperparameter optimization, transfer learning, and image processing enhancements to make the better model using this pix-to-pix model. Okay, thank you very much for listening our presentation.
Thank you, Dr. Marcelo. Please, do you have any questions for the presenter? So it was about kind of predicting, right, doctor? So predicting the depth based on the image that we analyze using the technique. Is that correct? Dr. Damawan, can you hear me? You are muted.
Yes, that's true.
Oh, so that's true. Okay. I was wondering, did you also evaluate the usability part of your research? So you kind of did you have any user study? In addition to your evaluation that you have made, that you have conducted, did you also carry out some user study to get some usability scores from the users? Kind of try to ask people whether this results is different among across other results in terms of your depth image results.
Okay, so you mean testing the results from the modification, right? Testing like the sharing to other people to test.
Yes.
So
Yes.
currently we still not to test. We still not try to test in the real life.
All right, so your evaluation were limited to those two scores, right? So the D and the G, what was that? And then
Yes, discriminator and generator losses.
Okay, got it. So if we do not have any further questions from the audience, we can move to the next presenter. Thank you very much, Dr. Gamawan.
Okay, thank you. Thank you very much.
And now for the we are down to the last presenter. I believe Dr. Sohan is here. So you are going to present your work offline. You may put your notebook here and there. As long as you can conveniently check the solution. Yes. Oh, okay. Yes. Great. So it's not necessary to link up the cable, right?
Yeah, to operate it.
All right. Okay. You should reset the timer. Dr. Sohan is with State Polytechnic of Malang, Indonesia, and all the others are also from the same university. Okay, he will talk about indoor building room navigation using AR and SLAM method. Okay, time and place is yours.
Okay, thank you for the presentation. I present our study about this one for building room navigation using AR and SLAM method. In case study that we use this in Malang, we the authors is from this campus. So this is the outline. I will present you to the introduction. Basically, the navigation or navigation system or application has been used widely. For example, if we want to go to somewhere, we want know about the destination, we will use some application like Google Maps or Waze or another thing. So based on this case, we investigate something about the problem in our campus, which is in our campus. It uses a sign system. If you're familiar with this sign, this one is sign system. Sign system to navigate the user or the academic students to go to some places. And then we conducted empirical study, and then we share the form, and then we get 100 data, and then 84% from the lecturer and the students and the other in campus had difficulty finding a building or indoor room. Yeah, that's the reality. Even that's from the lecturer or student which is in the higher grade or the first grade, it is a problem. And then from recent study, we investigate, we develop study to use AR to navigate the users into some places in our campus. And then we get some insight. That if we use GPS, it will be a problem when we want to find a place indoor inside the building. Yeah. And then we think that we can go through some solution to develop another approach and focuses in indoor navigation. Next. This is the study of indoor verification. The first one is design a mobile interface for notification system, and the second one is using integrity technology in finding, and the third one is the markerless compatibility notification system with multiple touch display function. And then from another related study, we get some conclusion that if we want to navigate the user when we use the cases in our building. And then there's some problem with GPS or Wi-Fi and Bluetooth. Yeah. So we can find some solution next. And then we find this one. Basically, SLAM is a method. SLAM is a method that can this method can make image, can make the image from the sensor into some environment that SLAM is a method that usually used in robotics field. Yeah. If you know about the robot, that it can anonymously find some places, it uses SLAM. Yeah. So this approach is that we use. And then next, the SLAM method right now is included in our core in our core module. So this is the implementation, the architecture of our system. We use some services from Google, and then we store our root data in Firestore. And then we use Maps SDK to get the location, the latitude and longitude of the room in some building, and then the AR core is will be the engine to the process to get some direction. And then it implemented in mobile application. Then the user must scan the QR code in every floor in the building. So next. So this is the mechanism. Yeah. For example, this is example of ID building in 6th floor, which is this one is the lobby, and then these are the rooms. And then we place, we put QR code, and then the user must scan the QR code, and then the application will navigate the users with AR, so it will show the object. The object will be shown in the floor to navigate the users into their destination. Then next, so this one is the example. This one is video. Can you please play it? Yeah. So the first one, we choose the building, and then we want to choose the room. Then click. Scan the QR code. Okay. Okay. And then the library in AR it will detect the surface of the floor and the building. It will show the object to navigate the users into the destination that we want to go there. Okay, so this is the sample for this application. The application we call it P9, application with augmented reality. Next. Yeah. So after that we conducted some test. Yeah, we test some functionality. This is the example. And this is the example. We do some tests in IT building and electrical engineering building. And another building, and then we get conclusion that 90% of our test is has been succeed, but there are 10% that the cases is failed. Yeah. So we do the next test. Yeah. And then next we do some tests. We want to check if some devices with some different environment, but we get three devices, but these devices in still in the same OS. They has they has different camera, and they has different hardware. Yeah. Then we define some criteria. AR floor objection, AR room object generally on its position, and then navigation road directing to road destination, and then the objects recover when lost tracking. And then we get some insight, but not all the devices show the direction correctly. Yeah. So in this case, when the objects lost tracking, and then if the object was tracking like such the head should be right there, and it will be over there. Some devices cannot recover the object into the true path. Yeah. Next. Then from these test cases, we can conclude that 90% of sample testing is successful, but we get some problem, which is if the floor, if the floor has the color nearly the same with another surface like this one, maybe it will show an error or failure in directing the user. Then, the camera, the surface color, and the lighting can be affected on the accuracy. And then, so this one is maybe the further work. Yeah, the further work we don't implement some short spec algorithm. So we didn't test about the performance of pen finding in implementation. So that's it. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Please give round of applause. So we encourage any questions from the floor. Do you have any questions? Alright, it's quite interesting because it's actual case, right, in your university. Maybe I have one question there before you answer, which is about the strategy of yours and your team to locate, because you said that you didn't use any pathfinding or shortcut or short pathfinding algorithm. So how did you manage to have that arrow on the floor?
Okay, thank you for the question. Please open to so thank you. Maybe I forgot to explain this one. So before we implemented in the application, firstly we record the position, the latitude and longitude of the room, the one by one. Yeah. And then after that, we get the position in this one, yeah, from the junction. So we get the latitude here, latitude here, and latitude here. So basically, this one is some nodes here, some nodes. Yeah. So the application can be ranking the user based on the room that they want to put. Yeah. So that's it, I think.
All right, maybe you could also share with us your attributes used in your database, in your team. So what, in addition to the latitude and longitude, is there any other attributes that you employed in
Okay, thank you. In any other of the attribute from latitude and longitude, we use another attribute like it is like program, yeah. We store the data of its neighbor nodes, yeah, like this one. So if you want to go to room 1, it will find here and the nearest neighbor of this the data stored in Firebase.
Okay, understood. Okay, thank you very much, Mr. Luhan, for your presentation, also for all of your answers to the question. Please give a round of applause again. Before I wrap up the session, maybe I need to cover one more time, once again. Dr. Fatima, are you with us in the Zoom meeting? Dr. Fatima? And Dr. Fatima?
She's still not here.
Alright. Okay, so we can call it a day. So this is the end of our session. Thank you very much for all the audience participating in this moment, in this session. We really appreciate your attention and also to all the presenters and the audience for the hard work, giving us a lot of insights in this session. And after this session for the presenters, I would like to invite you to go to 107. So there will be our chair. I don't know what's going to be there, but that's the message from the committee. And then I would like to inform you that the certificate and later information will be sent to you. Okay, that's all. Thank you very much again for your attention. Good afternoon. Assalamualaikum warahmatullahi wabarakatuh.